Alright, now let's have a look at question 11. It says to write down the coordinates of the vertex and the concavity for each parabola. Hence determine the number of x-intercepts. So don't forget that when we have it in this form, y equals a outside of x, take h squared plus k. The h is the axis of symmetry, which is the x-coordinate of the vertex. And the y is the y-coordinate, the k is the y-coordinate of vertex. And if a is positive, it's concave up, and if a is negative, it's concave down. So let's do question 11b. We've got y equals 3, take x plus 1 squared. I'm going to rewrite this so it looks more like my turning point form, y equals a outside of x, take h all squared plus k. So I'm essentially going to move the 3 to the end, and that's a positive 3. So I've got negative x take plus 1 all squared plus 3, which means, well, first of all, concave down because there's a negative out the front. A is negative 1. If there's no number out the front, that's a 1. The vertex, the x-coordinate, which is h, equals negative 1 because there's a plus in the middle, so you change the sign. The y-coordinate, which is k, is positive 3. So the vertex is at negative 1, 3. So that's where it turns around. It says to use those to determine the number of intercepts. Now, if we've got a sad parabola and its vertex is at negative 1, 3, let's have a look at that. Let's graph something. Why not though? Okay, x. So we know that this is going to turn around at, this is minus 1, this is positive 3. It's going to be turning around here at this point. And we know it's a sad one, so it's going downwards. So because it's turning about above the graph and it's going downwards, then we're going to have 1, 2 x-intercepts. If it had been a happy one, which it wasn't by the way, if it had been a happy one, then we would have had no x-intercepts because it would have kept going up. But we didn't have a happy one, we had a sad one. So 2 x-intercepts.